In Unit 12, we're going to look at some vision-related tasks in artificial intelligence. We'll start by looking at the Stanford AI class information. So this is in this YouTube playlist. So Stanford looks at how images are formed and different things about simple camera angles and that sort of stuff in this first set of units. While this is important to understand some basic image processing things, it's not critical to what we'll be doing. So we're going to really skip over this first 13 segments on vanishing point and lenses and stuff and get down here to where they start this 14th video and start talking about invariance. So invariance is really important in vision, how to create features or work with images in an invariant way and different types of invariance. So it's a good introduction to invariance. And then we move on to feature extraction and talking about linear filters. And we'll look at some basics of linear filters. So like in this unit 34, he talks about applying this simple filter with a -1 and a +1 to an image. Like this. I'm going to pull up a different example. So here we've got a grayscale image, and every pixel in this image is made up of a grayscale value between 0 and 255. So if we look at a small region of, let's say, 4 pixels by 5 pixels here, here could be the grayscale values. So some of them might be very light, like 250 and 233, and other ones are light, and so this is like a 17 and 18 and 9, 2, 3. And so we're going to bring up this little filter. Again, the filter has a -1 and then a +1, a -1 on top, +1 on bottom. And what we're going to do is we're going to apply this over this image. So first we're going to apply it to these two values. So if we apply it, the -1, +1, here, 250, so we got a -250 and +250, so it ends up to be 0, so we'll end up with a 0 in that location. So I'll bring up a little spreadsheet. I can kind of store these values here. So the 250 minus the 250 is there. Now this next one is going to be a -250 plus 17. So -250 plus 17. And this one will be -233. And then now this one is going to be the 17 minus 7, or actually -17 plus 7, which is a 10. If I go through this image and do the same thing, here I've got a -33 and 250, and I repeat this for a couple times here. So here I've done the next row, -233, again applying -1 times the top number and then adding in the second number. So I've applied that. Oops, let's try this again. Get all my things up here. Okay, so I've got 233 minus 233 plus 250 is a 17. And again, here I've got a -250 minus 18 for this group. So I can go through and apply this simple filter to all these images. And what I find is that this filter will detect a vertical line, horizontal line. That this here, we have a strong horizontal line where it's black on one side and white on the other side. A pretty abrupt change from a lot of black or really dark gray, and then a lot of real bright colors. And so this filter detects that and will highlight those. So most of the filter will be bland, very little color, and then there'll be this bright dark value here where the filter is applied. And so again, the videos walk you through these simple filters, simple 2 cell filters, and then up to more complicated filters that we work on. So we have some different filters here. There's like the Sobel masks and DeWitt masks, and some of these filters are wider or bigger, often they are 3x3 filters, and we apply the filter to the image again and again. So we'll apply a 3x3 filter to a whole range. Now when you're applying a 3x3 filter or bigger filter, you've got to watch things like the edges, and there are different ways of handling the edges. Often the edge value is just copied above and over to the left or right to extend the last value over. Sometimes we do other things. And then we'll apply the value and then move the whole filter down one and apply it again, move the filter down one and apply it again. So we have these different filters that are applied to these images to try to detect lines or corners or different values. And you've probably seen in programs, graphic programs like Photoshop and stuff, they have a wide range of filters you can apply to images to detect edges or different values. Now, this gets more complex when we get to what is called face detection. And so let's talk a little bit about face detection. There's something called HAR feature detectors. And again, we're applying these filters, but it gets a little more complicated. Here's a video on face detection that I find very good. And it starts off with some real basic stuff, but right around 3 minutes 20 seconds, it gets into these HAR filters. And again, what they're applying is these filters where they're trying to look for some light and some dark and some light values and applying these to the images. And they have some slanted ones and different filters. So they're applying these different filters to our images. And the tutorial walks you through how these images are applied to values. And then we use cascade, so where one filter won't detect faces very well, when you have a whole set of filters applied and a number of them fire or return good values in some areas, that's real positive, and you can identify faces that way. We also have to worry with images on what size the face is. Is it small or large? Now, I was hoping to have you actually work with a Java program for face detection, but I'm having trouble making this portable so that you can install it on your machine. So I'm just going to show you the code and talk about it. So this is Java code that uses these HAR cascade filters for face detection. It uses a library called OpenCV, Open Computer Vision. And Open Computer Vision is a large library written in C, and there's some Python interfaces too. But it's not written in Java, though they've just added a Java interface to it. There's also a wrapper around it called Java CV. So when you're looking at examples online, you have to be careful. Some of them are for Java CV, and some of them are for the relatively new Java interface to OpenCV. This is the Java wrapper to OpenCV, and it uses these libraries where we are given an image and we create one of these classifiers with this classifier files, which are these XML files, and then we can detect images and draw rectangles around it. So it's not a whole lot of code here. We're just loading the images out there, and then we're calling this face detection. And this one call calls the library and applies this HAR tool to it. And again, that's described pretty well in this algorithm, how that HAR code goes. But if I run this, I can actually detect faces. Let's see if I can get this running. And so there's just some sample images from students we've had and different images that have been around. Okay, so we're doing some face recognition on these images. And again, you can see, oops, let me get these up. Okay, so here's a group of students, and it's detecting some of the faces, but not others, depending on the angles and the glasses and stuff like that, what faces it'll detect here. Let me try that again. Okay, let's try this again. So here, again, it was detecting some faces, but it was missing some faces here. Sometimes we also get what are called false positives, where here you can see it's detecting lots of faces all over the place. It does detect the student's face, but it also detects other faces. It's interesting, it does detect this face, which is kind of drawn over here. This one, it seems to detect this face fine, and some of the filters were actually to detect this face on her shirt. And again, here we're detecting some faces fine, but again we have some false positives. It seems to think that these lights with this clock, looks like a face, so it detects it twice for this. Now there are different types of filters that you can run, and you can train these filters to recognize different views. So there's actually cascade filters for front faces or profile faces, or just recognizing eyes and things like that. Let me run another one to show you. Okay, hopefully I have everything in your field of view here. So here we're detecting some eyes. Just again, this is trained just to detect eyes. And again, we're getting some false positives here where it's detecting eyes in different locations. So again, this is not doing very well. We're detecting some eyes, but we're getting false positives for this here. So it's set up only in certain constraints, and the HAR filters by themselves sometimes do not work as well. But software is getting quite good at applying these filters and recognizing images, and it's just and very quickly doing that. In fact, you'll often see Facebook and cameras and things like that running these sorts of filters to quickly detect faces. So we won't be actually doing any face recognition packages today because, again, some problems I'm having with getting OpenCV in the libraries in a packaged environment. I could have you install it, but it gets rather complex and takes quite a while to download and install the OpenCV libraries. But if you do want to play with image recognition, face recognition and stuff, I can help you out. Just contact me and I can send you some instructions on how to get OpenCV running with Java. So, and again, I suggest you watch this video, nice introduction to HAR cascade filters, and along with the YouTube video from Stanford, which walks you through initially how these image detectors are run. So hope you enjoyed chapter 12.